So like I said, today is implementing some basic data structures, and we'll see if we have some time at the end for other questions and things like that. Here are the ones that I came up with, but I'm curious, are you interested in these, or are there others that you would like to work on?
I'm interested in the last one the most.
The Hashmap, yeah. I put that last just because it's the sweetest.
It's a tree. When you say trees, I mean like binary search trees and other such tree implementations.
Yeah.
Okay.
Yeah. So it could be a tree of any kind, binary search tree, and trees, of course, are just kinds of graphs. So.
Also, sorry. Also, one I'm interested in is the directed graph.
Directed graph, eh?
That's one I'm really interested in.
And what has you interested in that one?
It's just basically like I've attempted it once before and I haven't fully completed it. I think my understanding is still not solid. My understanding is that what they use like the Google Maps and lots of other maps that ways, and I'm really interested to get a deep understanding of it.
Mm-hmm. Okay.
Yeah. And then a doubly linked list because that's how blockchains are built.
Yes. Is it a doubly linked list or a singly linked?
It's double linked because it points forward and backward.
Okay.
And the for the directed graph, maybe the tag to the directed specific graph. Is it the one that we use for most crypto blockchains too? Mm-hmm. There was a talk yesterday actually at work last night.
Yeah. If you guys haven't checked out graph theory, it is so interesting. Graph theory is like literally, it was like in all of my education, one of the most interesting things, this question of like, you know, you've got graphs, but then you've got like balanced acyclic graphs, and you've got, you know, calculating Dijkstra's algorithm to find the shortest path between, you know, and it's the kind of stuff that is behind how Google Maps is able to plot a route from San Francisco to Connecticut in like a quarter of a second, given all of the possible roads between there, you know, and it's just, it just blows my mind. I thought just to kind of get us warmed up, we'd start with a stack, like an easy one. That sound good? All right. Data structures. Yeah. Yeah, so what is a stack? Say it again, Miles.
I thought it was first in, first out. You can say first in, last out.
First in, first out. Last in, first out. Yep. Last. Yep. So if you put something on a stack and you go to get something from a stack, that will be what you get. The last thing that you put on will be the first thing that you get. Last in, first out. And what are the operations that a stack needs?
Add something to the stack and pull something off the stack.
Mm-hmm. So that the correct terminology is push onto the stack, and that is like an element. Pop will return an element. What else? You could, yeah, it's not a typical one, at least in the kind of basic implementation, but we can put that in there, length. The more common things are peak, which lets you see the element on the top without actually popping it off, and is empty, because you do have to know at some point, like, are we at the bottom? So so somebody talk me through this. We're going to do a class called myStack. And what do we want? Constructor. And what's the constructor going to take?
You can take it.
Uh-huh.
You can just not have it take it. It doesn't need to take it.
What's the argument for having it take something versus not?
I would say push like the first object onto the stack. If you want to push it as soon as you create it, you can have your constructor set up like that. But if you want to be able to do stack equals new stack,
Mm-hmm.
then the next time you want to do stack dot push, then
I guess it could be where you don't require the constructor to take a thing, but if it does, we should do something with it.
Mm-hmm.
So it's like you can just call new my stack, but if you do call new my stack and pass something to it, then
Mm-hmm.
you can take first element and actually go ahead and put it in the stack.
Man, getting a lot of linting errors here. So does everybody know about default, what's it called? Default values. Is that what it is? Default values? Default parameters? Yeah, that sounds right. It's a new syntax, I think in ES6, that allows you to take in arguments, but also in the argument line, specify the value for it if nothing is passed. So you could do, x equals 6, and then if someone passes something for x, it would be whatever they pass, but otherwise, x would be 6. So pretty handy.
Sorry, so you specify the value as an argument. You specify the value of it when you pass it to the function?
So you list the name of the argument. So in this case, the variable name is, or the argument name is x. But then you use an equal sign to tell it what the default argument would be if nothing is passed. Yeah.
So it doesn't just but are we just being super verbose? But I feel like for something would be enough time to pass.
I think that would be a fair assumption. My strong leaning on this is to not have anything, because it's, you can think of a few circumstances where you'd want to instantiate with like one thing, but most of the time you just want to create the thing, then you want to do the operations. So I would do it like this. And then what do you want to put in the constructor?
Blank array.
Blank array?
I mean, are you trying to implement it with an array or something, or are you trying to use like another data structure?
I have another with that.
With an array?
Yeah.
From scratch?
I would say like the first thing is with the length of 0. So we can have like a counter that whenever we add an element to it, it keeps check that like it's start with a 0 and then an increment that based on the elements we add into this. That's the first thing I think of.
Okay. So the first question is for us deciding what data structure we're going to rely on to implement this. And on a much more like system level, like the JavaScript V8 engine, it may use an array, it may use some other like lower level data structure. For our purposes, let's use whatever we got. So I think an array is the right way to go. And so we can call it this dot stack. Yeah. Yeah, I was going to say data. Let's go with Bob's route,
Yeah, storage.
Storage, this dot storage, and we'll make it an empty array. Need anything else in the constructor?
I would say, this dot length equals 0. Oh, this dot count equals 0. So we can. Oh, sorry. No.
So I feel like we can query if we wanted to get it, we could query our storage object or in this case array and ask it what it is.
Yeah.
So we can
Yeah.
like pass that through. So like whenever we create our get lane for our my class stack, we'll have to go to this dot storage dot lane and get that and just pass it back up.
Mm-hmm. Mm-hmm. Yep.
And what about the is empty? Do we need to do anything with that? Or do we need to initially?
So let's write some functions. So first one is empty. Takes no arguments, and what do we return?
We're just gonna write the same and say if this dot storage equals 0.
So storage dot lane.
Yeah.
That is
Mm-hmm.
Pretty good.
Yeah.
What's next?
I guess we go ahead and get length out of the way. This return this dot storage dot lane.
Okay.
Does that have the length as just a property and not a function?
Say that again.
Do you want the length to be a function or just a property of the stack?
So if we,
I would just set it as a property.
yeah,
Is that length equals 0 in the constructor?
So then how would you, so you want to, in addition to adding anything to storage, that go up, you also want to choose a property to add.
Right.
Or you just want to add storage.
Yeah, that's a good idea to use the array like.
yeah, and so in this case, it makes a lot of sense to just compute the. So there's properties which are just kind of dumb variables that get set, and then there's computed properties. So length would be a kind of computed property. It's actually a function in the way that we're implementing it, because we need to go and get something else.
So you become the get length or something like that. It's more kind of descriptive.
I don't feel strongly about that. You could, but it's clear enough just length that I think we could just stick with that. Like, I don't think anybody's going to see that function and be like, what does this mean?
No, I mean, it's not like it's kind of in dryness because I'm like looking at both there's like both words right there.
Oh.
Uh-huh.
Like when you look at it, you know, right away, there's like the two. It's like the same
Line
word,
17 and 21.
the same word in two different contexts. You know what I mean?
Yeah, this and this.
Yeah, it's the length and the length. Right?
Yeah, which is why I probably wouldn't implement a length function unless there was a special use case for this stack. It's not a typical thing to implement.
Sure.
And if you implemented length, you could conceivably remove the is empty altogether, or you could just use the length function to call it. I think this is fine for now. I wouldn't change it. So we've got that. How about push?
Yes, storage dot push.
That's the element.
Okay, is that it?
And then you can also.
What,
Do you need to return anything?
what do you think?
I don't think it.
If you were using a stack, you know, and you pushed something onto it, would you expect anything to be returned?
It'd be nice if you return this.
Why?
Yeah.
Yeah, so that's interesting. So if we return this,
Is the new this dot storage with the new elements at that point?
yeah, so it's not even the new one, it's just the same. So the this refers not to this dot storage, but this refers to the object, the stack itself. And so what it would allow us to do is if you did const s equals new my stack, and then we did, you know, s dot push howdy dot length. We could do that. We could chain that together, because push not only pushes the thing onto the stack, but then it returns itself. So this is kind of like just doing that, right? Is that making sense? So I think there are compelling reasons to have that as a pattern, especially in functional programming. That's like one of the things that makes functional programming really work, is being able to chain things.
Sorry, isn't the return value of the push method is only the length of the array, or is it the actual array? I forgot.
Say it one more time.
The return value of the push method, is it the length of, does it return the length of the array, or does it return the array itself?
Neither. So you're saying on line 26 here?
No, sorry. So if you have an array,
Mm-hmm.
A equals empty array, and say array a dot push 1, or a dot push 5, and then so is the return value when you enter like the terminal, is the return value is going to be 1, the length of the array, or is it going to be a equals array of what element 5?
Is it like an actual array? Like,
Yeah.
So let's take a look. Node. Can you see that okay?
Yeah.
Okay, so let A equal empty array.
You say a dot push 5.
Okay, 5.
What's your guess? Okay, so it's the length of the array, not the actual array.
And 4. Yep.
And
I didn't know
so-
that actually. I
and
didn't.
So the string dot push dot length here is redundant because just the stack dot push it will return the length of the array. Does that make sense?
Where string dot push dot.
When you had before. If you
Oh
click
yeah, this down here.
Dot push dot length because dot push actually returns the length of the array.
Mm-hmm. Without getting too far into this, all of this stuff that we're talking about, I think is up for grabs. I want to impress upon you that there's like not a right way and a wrong way when it comes to this. And everything has to do with the contract that you are creating with the users of your data types. So if you publish this on NPM, you want to write up some documentation that says, when you push onto the stack, it gives you back the length. And then anybody that uses your library just knows that. Somebody else could write another library that says when you push, it returns the object itself. And, you know, both ways are fine. My inclination is to go this route on line 26 where we return this, just because that allows you to call length if you want, or call anything else. So you could do, you know, push.push.push.push.push and add elements that way and make it really simple, you know. Clear enough? Pop takes no arguments.
You gotta check if you're empty or popping out. And if you're trying to pop out, then you would raise an error.
Okay. So if this dot storage dot length is 0, then
Why don't we just call it?
Yeah, I'm gonna say, yeah, why didn't we just use it empty?
This dot is empty.
I think we could. I'm a little more interested in interacting directly with the data type that we're using to implement this. Again, you could do it either way. Yeah, I think you could do it either way. So we could say throw new error.
Cannot pop empty stack.
Pop from an empty stack. Get a little frowny face in there. Good. And is that it? Oh, peak.
But you want to do the actual pop though.
Oh, yeah. Getting ahead of myself. So then what?
It's gonna be this dot storage dot pop. And then so don't we wanna oh never mind, sorry.
Oh, I'm sorry.
Yeah.
But do we want to do anything else?
That's for idea.
So return this dot storage dot pop, which in this case a dot pop, as I think we all expect, returns 4. Did it again and returns 5. Behavior here, yeah. Behavior for the array itself is if you're popping from one, it just gives you undefined. My Python sensibilities like throwing errors. Python is all about exceptions, which is the kind of companion to errors. Errors in JavaScript are like exceptions. And Python throws exceptions a lot, expecting that you'll oftentimes catch them, but it's a useful way to distinguish between like an array that might have one value be undefined. So like array element 0 could be undefined. And if you popped it, you would get the same thing and you wouldn't be able to tell the difference between one versus the other. Cool. So anything else? Peak?
Yeah.
What do you think?
We should take some argument.
It's just gonna.
We just got the last thing we did, right?
Mm-hmm.
The last
So this dot storage sub -1.
Sorry, is peak only checks the last item of the array?
It tells you what's on top of the array,
So
or what's on top of the stack.
So it's not meant to look through the whole array and return a specific element, just whatever.
No,
Okay.
No, it may seem a little restrictive to have a data type like this, but you'll find in the use cases for stacks, you don't often need to kind of wiggle your way into the stack and know what the third element from the bottom is and whatever. These are the operations that are kind of essential. So how do we do this?
Can you do a sub -1 or what do you call it? That's typed out, but the
Array,
brackets,
square.
not bells.
Can you do this? -1?
Yeah.
You can do it in Python.
You can do it in JavaScript.
Yeah, it's a lot of
No way.
Yeah.
Oh my God, that's so great. So a -1.
No.
Well,
I was.
I think that is with the string. I think you can do that
I'm pretty sure if there's one that had to do the whole like length -1.
Yeah, it's -1. There's a way to
Sorry,
do it
what do you-
in JavaScript.
What do you say? Index -1.
So I know that you can do that, but
And what is that supposed to
I think that
return?
is
it's returning it's taking the full length of the string. So it's like I have 5 elements in this array, and I want to hit the last index, which is 4. So you say keep it a length, subtract 1, it's going to go to the last one.
I think you're thinking of
Slices.
slice.
Yeah.
Yeah.
I'm pretty sure. I think it works with strings. So if you say a equals some string and say a sub -1, then it would be like the last.
I think the array that length -1 you use.
Yeah.
Yeah, that's good.
That's what it is, right?
Yeah. So this will work, right?
Yeah.
Cool.
So before that, you want to check if it has something. So you don't want to do peak if it is empty.
So you could peek it as fine.
Yeah, it's gonna sound defined as empty.
Yeah, I'd be tempted to actually explicitly like in other data type implementations like this of stacks, I've seen an error thrown when you peek into an empty. So I might do basically the same thing. Throw error cannot peek into an empty. What's that?
Oops, nothing there.
How does this look to y'all?
Right?
So we got.
Do we have it? All of
We
it
also
is.
so we want to do.
What's that?
We do everything so we want to do.
Yeah.
Push, pop, length, peak is empty.
Yeah.
Want to give it a try?
Yeah.
So let's do let s equals new my stack. Okay, so we've got that. And in Python, I know there's a way to do this. You can redefine how the JavaScript engine like prints something to the console when you just type the like thing. So we might want to think about doing that. So let's s.push miles and s.push Latoya and s.peak. There's Latoya and s.length. It's 2. Pretty good. And what's our last one? s.pop.
No.
Pretty good, right?
Nice.
We got it.
Yeah. It's dope.
Is empty.
Oh yeah. S dot is empty. True.
Word.
Cool.
What are some applications of this? Things that
Oh, you are going to find some algorithm challenges that where stack is the only way to do it.
Oh, really? Wow. Okay.
Yeah.
The Bitcoin script in place is stack based language.
Why wouldn't I just use array and only pop the fish?
You could, but what you're using is a functional stack. So
Is there a JavaScript stack already? Are we?
I don't know. I don't think. I guess I'm assuming that there's not one built into the language, and that there are a bunch of libraries you could get. What next? I would be down for any of these. I don't know that we'll get all the way through it, but
What is a cube different from a stack?
good question.
It's the reverse.
So this is last in, first out.
First in, first out.
First
So
in.
change, push to shift, or pop to shift.
Yeah. So the operations on a queue are NQ, DQ.
Is empty also.
Is empty.
And length as well. The queue.
Yeah, you could do length. I don't think that one's necessarily part of the kind of like core spec. And then I think there's probably a peak here too.
And
Right.
then also there is a priority queue.
Yes. So priority queue. Let's get into priority queues next time. Yeah. I'm going to next time. What the heck is a priority queue?
Yeah, they were part of the original goals, but they took them away. Actually, when the new program changed, but there was priority queues, sets, all those stuff.
So one thing to bear in mind, burn this into your brain. If you are doing a breadth first search in a tree, so or trees or graphs, you can search them in any number of ways. Two very common ways are a depth first search and a breadth first search. And a depth first search is where you go down a path until you reach like the very final end. And if you haven't found it, then you retrace your steps and then go down the next little path and the next little path. Breadth first looks at it. It has the effect of looking at everything right around the thing and then keeping going and keeping going and keeping going. And the secret to implementing a breadth first search, like I know we haven't even really talked about what it is, how you do it, what the pseudocode is a queue. You've got to use a queue to implement it. So just log that in your brain. Why don't we do a doubly linked list? Unless someone's dying to do a hash map, and we can talk about it for 10 minutes and see how far we get. Okay.
Like if we do Hashmap another lecture.
Yep.
That one's also a good one.
Yep. So let's make another class. Doubly linked list.
How do we basic JavaScript?
The hash map?
Yeah.
Oh, it's so interesting. It is.
How do we implement something?
I mean,
the most minimum thing we can use is an object.
Yeah.
How do you make an object out of an object without just like objects?
I promise you it's going to be so interesting because we're going to talk about hashing algorithms and we're going to talk about collisions and we're going to talk about linked lists and yeah.
So correct me if I'm wrong, but a hash map on the internet is an array of linked lists.
That is one way to implement it. Yep.
I was actually going to say an object linked list.
An object is itself a hash map.
Right, because like my understanding is that you wanted to have to target this element directly without looping through the whole thing. So with the array, you still have to loop through like one element at a time. But if you have an object of linked list, you can decide to target that element and then loop down the linked list. Like if it's Spotify, you target that one artist and loop down all the albums and songs there. So it will be easier to implement with objects.
Except an object, like when you're talking about an object is already a hash map.
Right.
And
Well,
so to do it that way would either be not very interesting or kind of like cheating, because what we want to do is create what an object does, and we want to do it without using an object itself. But let's bang this one out. I think we can do it. So what's that?
Look at these array.
So I created this class doubly linked list, but does anybody have a hunch why this might not be the best approach based on our conversation before about linked lists? Boom. Because a linked list even a doubly linked list is just a collection of nodes. And you could create a container object for it, but it's not actually that useful to do so. And the container object isn't very interesting in and of itself. So, and if your brow is kind of furrowed by that, I think you'll see why when we get into this. So let's create a doubly linked list node. And I do not I do not condone a class name like that, but I can't think of a better one. So so what's the constructor for this one?
That's gonna be this dot.
So what does a doubly linked list node need to track?
Itself and what's on the two sides.
Mm-hmm. And we can track ourselves by this, so that's easy enough. And
It's like it's not data or
Mhm.
not something.
yeah, so we can have a data value, and this could be anything, right? You could use a doubly linked list for whatever you want in the world, and data could be some massive object. You could have all sorts of other properties, but for right now, we'll have some kind of data, and then we'll have this dot next and this dot prev. Good. And do we want to take those in as arguments?
I don't want to take the data, but we can. If you want.
Yeah, with linked lists, it turns out that it's nice sometimes to be able to create something and kind of link it up all at the same time. Yeah, I mean, let's just do what Bob was saying. So data, and we'll just say this dot data equals data, and we'll leave it at that. And this can be null, and this can be null. Okay.
I don't know if that's related to what we do, but like on line 56, this dot data, I would go with Miles like first to show that this dot self, because like data could mean a lot of things. Like this dot self is very specific, like this specific.
Whenever I've seen it like on HackerRank or wherever they were giving us some type of like node situation, they seem to like to use some. I don't know where that KM comes from.
You know, the only reason I wouldn't do that is I think it's a little confusing, because what does self mean when really that property it's some kind of label, it's some kind of payload or data or something like that, and this dot self seems to it would confuse people and have them think that it's like this keyword, you know? Is that making sense?
There's no this, instead of this you use self. So they literally mean the same thing in two different languages.
So is that what it is? And it's a different language where self is a keyword?
Yeah,
Okay.
self is like this.
Yeah.
I just learned from Puneet that he avoids using like whenever he defines something, he avoids using data because it's very general. It could be like a lot of things. So it can use the person who's trying to read through the code and see what is this exactly.
Well, Puneet's not here, is he?
Right.
Yeah. Yep. Yeah. That would be the other thing. So what else do we need for our doubly linked list node? We do?
No. That's pretty much it. We should be able to set previous and next at any point by calling whenever we decide to assign these classes to a degree.
Well, if we had ran that inside of doubly linked list pattern, we could do a for each kind of thing, right? We can say w linked list dot for each thing. It wouldn't know the first node. I guess we can still do a for each inside of this.
How? So you want each instance of the BLL class will know about all the other ones?
Not each, but only the head.
So yeah, so this is an interesting idea. So you're saying implement on the node class something called for each.
Yeah.
How I'm so intrigued by this. How would we do this?
So we would take a callback as an argument.
Okay.
They say just call back, and so you say this head equals. So this would assume that you're calling for each on the head node.
What if we had it so that you could call for each on any node?
They're making it a property of class, so it shouldn't apply to anything.
Right. Would that be a thing? Should we do that or not do that? Because we don't want to be able to say node fifth node dot for each, because that doesn't really mean anything. But we could do doubly linked list an instance of that dot for each, which would automatically grab the head.
Mm-hmm.
And then perform the source.
So what if we had a class doubly linked list? What would the constructor have? This dot head equals, and then we take in a head. And this is why I was saying it's kind of boring, because in your code already, you're probably going to be tracking the head. And so to create a whole class just to point to the head is not particularly useful. But so there is a way, I think, to do a for each on the node itself, and I think that would be fun to do. We could also do it here. So if we do for each, takes a callback. What do we do next?
So you want to while, so let's make a variable. Say let current node equals this dot head.
So let current node equal this dot head.
And run a while loop. While current node is not equal to null.
Is not equal to?
Null. Inside the loop, say current node equals current node dot next. So before that callback with current node dot value or dot data. And yeah, wouldn't that do it? So now you can say W make list dot for each a function that takes the data and you can figure it.
So yeah. So yeah, and the reason I'm pausing for a second is because there are versions of doubly linked lists, I suppose singly linked lists too, that are circular. And so if we wanted to allow for that, because currently there's nothing stopping someone from connecting nodes in such a way that it's a circle, we would want to account for that. But assuming for right now that we've just got a doubly linked list that's like, node and then node and then, just it's kind of one directional, then this should work. Yeah, this should work. Want to try it? And then I got to go for a meeting. Okay, so so we're going to create a doubly linked list equal new doubly. Well, actually, let's. Well, yeah, okay.
Let's grab the head first.
Yeah, so let here I'm gonna pop out of this and then start a new REPL and copy this in again. And then we'll do let a equals new DLL node. So we're going to create a couple nodes. And this node will have the data A, capital A. Let B equal new doubly linked list node. And this will have label B for data B. And we'll do one more. So now we can wire them up together. So a.next equals b. b.next equals c. And c.previous equals b. And b.previous equals a. Yeah, so you can actually see the entire structure here, is that it's A, and then its next thing is this, and then for is this node, and then for B, its next thing is this other node, right? It's kind of an interesting representation of it.
I like how it recognizes that this is not necessarily a problem, that this could be circular.
Uh-huh.
As opposed to just like, I'm just going to keep giving you data that it actually sees that I've already shown you this somewhere else in that tree.
Yeah. Yeah, that is thanks for pointing that out.
You know, I think it's even much more intuitive to try to implement the linked list on the command line like this. Because before, I didn't do it. I did it all basically within the editor.
Uh-huh.
And I didn't actually quite break it down like this. But it's much more, visually, it's much more, actually makes much more sense.
Well, and again, you could create a function that turns a linked list into a kind of human readable string.
Sure, sure.
And you could have it just print out the data, and then like an arrow going that way and an arrow going that way, and then the next thing and an arrow going. So just an aside on this, I probably would implement a function or two on this. Why am I saying this? I would implement a function like append or add or something like that, and have this take a new node, doubly linked list node, and that doubly linked list node, then we do this dot next equals doubly linked list node, and doubly linked list node dot previous equals this. Why would we do that?
So that you don't have to set up your previous and next every time you're creating a node. It automatically does it.
Mm-hmm.
And also, if it's the head node, are you appending to something are you appending to something that already exists? The linked list already exists, or is it empty?
So this would be, you have a node, you want to add another node on the end.
Right.
So this is under the assumption that you do have nodes. Right?
Well, because this is a node. So the only way you could call this function, the only way you could call this function is if you already had one node.
Are you appending to the front though?
You're appending to the node you're talking about.
And putting it at the end where the rest of this was this one new node. So he's losing all the data that was after this.
Okay, so
Because everything the next that this was pointing to is now gone.
You could do this. You could call it set next. That's probably a better label for it, because you're, even if something else was set as your next, you could call set next and it would do this.
yeah, this makes a lot more sense.
Now, why do this? This is an important question. Why write a function like this?
I'm still not quite sure why I'm trying to attempt on this one. Can you elaborate more, please?
I can. So
every time you add a node, you can just say
you see the nice label up here, phase 3, do not move.
But the problem is that you're still on the first all segments.
So you've got a node, it points to this other node, and that other node points back. So this is a linked list. And maybe this one points to another node, and this points back. And this could be A, B, C. So that is a function so that you could do, say C is represented by a lowercase c. We said let lowercase c equal this node. We could do C dot set next. And here, let's do let D equal new doubly linked list node. And that's E and I'm going to fall off the end here. And then you could do C dot set next with E. And what effect would that have? It would make this connection to E.
So skip C.
What's that?
It's skip C.
Or you just switched D and fill up a piece of paper.
I'm so glad you guys are paying attention. Yeah, just for the
That's why I'm like, I still don't understand what
Yeah.
D. There it is.
Okay.
D.
Okay. D.
Okay. So here's what I'm trying to get at. Without a function like this, you are leaving it up to chance that when someone adds another node, they are going to both make this connection to, now let's say we have an E, and this connection. You are relying on the user to do two separate operations that maintain the integrity of your linked list.
Okay.
A linked list is nodes where one points to the next and that next points right back to the same one. But it's possible, without that function, it's possible that someone could, gotta have an eraser around here somewhere. It's possible that someone mistakenly or intentionally could create a new node. So they do let E equal new, doubly linked list node E all the way down there. I promise my marker skills will get better. So E is now a node just kind of on its own, and you could say D.next equals E.
Right.
And then not say anything else.
Okay.
Or you could say E.previous equals A.
Oh, that's not the connection together.
Right? You lose the integrity of your linked list. And this is one of the most important things when you are creating a class, a data type, something like this, is being attentive to the possibilities for someone using it to actually break it, basically. And so if instead we rely on this set next function, we know that every time someone sets a next element, it's going to be hooked up in the correct way. Right?
Are we going to do insert operation or just
So this would be the insert operation. We could write an insert operation that says take what we've got here, insert a node, and kind of wire it up. So you could say, you make a new node Z and connect it like this, and this would go dot to Z.
Z back to B?
Right. So before you move this next, place the DLL node there, you give DLL node the current this next, and then you make DLL node with this next before you actually write this current.
So if we were going to insert a node, how would we do this?
On 77, I would say DLL node dot next because this dot next, and then
which node would we call the insert?
the one that you want to insert it after. Like if we're looking at this, we
Yeah.
call it on insert. Right.
So oftentimes in a case like this, you can do this in like a couple lines. I like to add at least one line that's like const next equals this dot next, because you're going to be overwriting next and previous, and this gives you a pointer to what was the next node. So in this case, it would be, if we're calling this on B, the next node would be C. In our example, this is C. So then, somebody want to walk me through this?
I guess you wrote someone for
The
previous
as well.
and like a next. Well, no, next is previous plus. You know that, right?
So
That is what the next is doing already.
Well, he's saying he wants to tell C about the yellow node.
so look over at the diagram. Let's do each of those 4 arrows, those kind of new 4 arrows. So from B to Z, that's this.
I think the first thing we do is to link C to C before disconnect B.
Okay.
Because if you disconnect B, then you would lose C's information. Then now your head's going to be C and you lose A and B. So I think my understanding of the first, we need to.
So we have 88. We have 81 already, which is telling this C node about C, and we need to tell C. We need to tell this dot next that its previous is the yellow node.
Okay. So
we can just stick it in there.
So DL node next equals.
It'd be this dot next.
We can just use DL node prev equals this.
But also this dot next dot previous.
Why not this dot next dot previous?
Yeah. Is DL node. So that you tell C before you throw C off into the ether, you tell it that its previous is not B anymore, it's DL node.
We're not throwing C off into the ether though, because C is this underscore next. We're never going to lose that sucker. So this dot next dot previous is a code smell for me because that is just confusing, you know? So bear with me for a second, and then we'll wrap up. So the new node, doubly linked list node. So this is Z. We set Z next to be C, and we set Z previous to be B. And now we have 2 more things to wire up, which is this dot next needs to be Z, and C. So by underscore next, C dot previous needs to be doubly linked list node.
So it's taking force.
And you could, in this case, still return this. Or you could return, in this case, you could return next if you thought that was somehow advantageous. Is this helpful?
Yeah.
You having fun?
Yeah.
Yeah. I had to steal that whiteboard back. I just and I need you to help me guard that thing. Good. I'm a little late for a meeting, but thanks everybody.